Hi children, I hope everybody is fine and staying safe at home and you are going through all the online classes. And now we are going to move to the next lesson in physics in class 9. But we'll just have a small recall of the previous lesson. So in the previous lesson, the chapter name was motion. So in motion lesson, we learned the physical quantities which describe motion like velocity, speed, distance, displacement, acceleration. And then we also learned the three equations of motion. And we all know motion is nothing but when an object moves from one place to another, it's said to be motion. And few graphical representation also. Okay. So today we are going to move to the next lesson. But you people are going to guess what is going to be the chapter name. So I'll just images here. So the first one, so you can just look at it. So the person is kicking the box. Okay, fine. The next one, so he is pulling something here. So both the images, if you have seen, what happens is both the objects are moving here. So our next lesson is going to be what is going to be the cause of this motion here. How this motion is being caused. What are the reasons behind this? How the motion is being caused? So as I said earlier, we're going to see what or how the motion is going to be caused. So what is going to be the reason behind the motion of the object? So here the lesson name is nothing but we are going to talk about forces here. Okay, so the main thing, the motion is going to be caused due to the forces. So we will see what are the types of forces and a few examples of the forces and what are the effects of forces also we will see in this lesson. And here also Sir Isaac Newton has played a very important role in the objects which are going to be in motion, and he has framed three laws. So we'll see all those laws here. So before that, today's session we are going to see about the force, what is force, the types of forces and effects of force, and what are balanced and unbalanced forces here. So first, force. So as you all know, force is nothing but a push or pull upon an object. So if you can see in that image over there, so the person is pushing and as well as you can see the person is pulling also. So when some force is applied on an object, what happens is the object starts moving here. So in general we say that force is a push or pull upon an object. So already you would have learned all these things in your lower classes, but we will just have a recall of it. Okay. And then what this force can do, we will see. So force is going to have both magnitude and direction. Magnitude is nothing but it's just a numerical value. So how much force you're applying. Suppose if you are going to pull that cardboard, pull any table, or if you're going to push any table, how much force you apply upon it. Okay, so that is your magnitude, and in what direction you're applying the force. So when force is going to have magnitude and direction, we can say that force is going to be a vector quantity. So in your last lessons, you might have learned scalar and vector quantity. Then, what is the SI unit of force? So the SI unit of force is Newton. So as Sir Isaac Newton dealt with force, so his name has been kept as the SI unit of force here, and as a unit of force you will be representing in capital N, okay, not in small n. And all forces, if you see, they are going to cause some motion here, whatever, even if you're just going to uh, push some object, even a light object, it's going to fall and then it's going to create motion. And then another important thing, the fourth one, you can see I've just put a star over there. What does it represent? That is, motion does not have to occur. So in few cases what happens is it is not necessary that motion has to occur also. Even after applying force, there won't be any motion. The object will not move. So how is that possible? Can you, I think by now you would have got some guesses and all. How is that possible? So all those things we'll see later. Now, the next we're going to see the types of forces. So what are the types of forces? The first we have like gravitational force, mechanical force, frictional force and all those things. So all these forces come under two main major categories. So what Now let's see about the types of forces. So all your forces like frictional force, gravitational force, magnetic force, electric force, they all come under forces only. But the forces have been divided into two. First one is going to be your contact force here. Okay. First is going to be your contact force. So what happens in the contact force we will see. So in contact force, both the objects, they will be interacting with each other. They will be touching with each other. They'll be in touch with each other. So very simple example, you are in the school and you have PT period and you go to the ground and you all play. And right now you cannot do all those things. Okay. So you go to the ground, you play football or cricket. So what happens there at that time? So the ball will be rolling on the ground, and after some time the ball will automatically come to rest. How is it possible? So there is some relation, there is some physical contact between the ball and the ground. So naturally what will happen, the ball will come to rest after a certain time. So that type of force, you call it as your frictional force here. And we have applied forces also, air resistance also. So for example, the same, you're playing in the ground and you're playing cricket, and the bowler is going to bowl the ball, and the batsman, you are the batsman, you're going to hit the ball. So what happens, you will use the bat, you will give some very strong force to hit the ball. Okay, so there is going to be some physical touch between the bat and the ball. So automatically what will happen, the ball will just go for a boundary or a sixer there. Okay, so that is an applied force. So everything, if you see, there is going to be some interaction, some contact between the objects here, the physical touch, pushing, dragging, pulling, all those things. When two objects are going to be in physical touch with each other, we will have contact forces there. The next one, we have your non-contact forces. So how is non-contact forces? So it will be taking place at a distance here. There won't be any contact. They will not be in physical contact with each other. Okay. Very simple example, gravitational force. That is how our solar system is, how all the planets are been revolving around the sun. Okay, it's due to your gravitational force of attraction. And then we have magnetic force and then electric force. So these are the two types of forces what we have. One is contact force and the other one is the non-contact force. The next one, we are going to see how these forces are going to create some effect. So what are the effects of these force? So you can think about it, how in what way the force is going to create some effect on any object. Already I've told it's push or pull, but in what way it is going to affect the motion, the shape or size of an object here. So we'll see one by one here. So the next is change in direction. So with the help of force, you can change the direction of an object. So the same football game. So two team players. So all the both the team players, they will think to hit the goal, right? They will. So what they will do? So they will be trying to change the direction of the ball according to their wish. And then for that, what they need? They need the force. So with the help of force, they can change the direction of the ball. So it's not only here, even in case of kite also. So what happens? The wind will be blowing in one direction. So according to the wind's direction only, the kite will also fly. So the other effect of force is you can also change the direction of the object. Then one is going to be with the help of force, we can increase or decrease the speed of an object. The same football case, one person is going to give less force, the other person is going to give too much of force. What will happen in that case? So you can increase the speed or decrease the speed of an object, or cycle you can take the very best example. So if you give too much of force, what will happen? The cycle will move. If you pedal very fast, you will move fast, and if you decrease your force, if you less the pedaling, what will happen? You will move slowly. So this is the other effect, that is we can increase or decrease the speed of an object. The next effect of force is we can change the shape of an object. So here I have given an example of the hammering of an hot iron rod. So when you hammer this hot iron rod, you can change the shape of it into a desired size or design. Okay. So for this also we need force. And a very simple example is in our home itself, all our mothers will be preparing food for us. That is, many of you will like chapati. So for making chapati, what your mama will do? She will be kneading the dough, right? So for that, you need to give lot of force, and then when you give a lot of force, you can roll them, and then when you can make them flat. So all those things, with the help of force, we can change the shape of an object also here. Okay, so we're going to see about something interesting, that is balanced and unbalanced forces. So if you see balanced and unbalanced forces, so I've given the picture over there. Have you all guessed what game is this? So this is your tug of war game. So we'll see what effect it's going to. So this is the very simplest example by which we can explain balanced and unbalanced forces very easily here. Okay. So first, what's the difference between balanced and unbalanced force? A very simple thing. So if you see here, in balanced forces, you will have two or more forces will be acting on an object, but how it is going to be equal on all the directions here. Okay, so all the three persons over here on the left, on the right hand side, their forces are equal. So 300 Newton and 300 Newton here. So what happens as both the forces are equal on both the sides, there won't be any movement at all. So in that cases, we call that kind of force to be a balanced force here. Okay. Then what about unbalanced force? Just opposite of it. When two or more unequal forces are going to act on an object. So it's going to be an unequal forces. The force is not going to be equal. So if you see the same tug of war here, what happens here? This side they are giving a force of 400 Newton, and this side they are giving a force of 300 Newton here. So in this place, what will happen? In which direction do you think the thread will move? So here, sorry, the rope will move. So obviously the rope will move the direction of the force which is greater here. Okay, so the rope will move the direction where a force of 400 Newton is being applied here. Okay, So that is the object will move in the direction where we have more force here. So what will be the total force in this case? So your total force will be the difference in both the forces which are applied on the both directions. That is 400 minus 300. That will be the net force, total force in this case here. So balanced and unbalanced force. Very simple example also we can say, you and your brother or your siblings or your friends in the class or in your home, okay, you're trying to, both of you are standing on the other side and both of you are pushing the table. So what will happen if both of you are giving the same forces? The table will not move at all here. The same thing here. So if we're going to have equal forces on both the sides, it is called as balanced forces, and balanced forces will not result in movement. So now we can recall the first slide what we have seen, that is motions do not occur in all cases. So what we are doing here in this place, we are applying force, but there is no movement also. In spite of applying force also, there is no movement. Why is this so? It's because of the forces which are balanced on both the sides here. And on, if you see in this side, both are unequal, not equal. So that's the reason it's called as unbalanced forces. So in today's session, we have learnt about force, and then we have learnt about the types of force, and we have learnt about the effects of force and balanced and unbalanced force. The next session, what we will see is, we will see the famous Newton's three laws of motion. Okay, so Sir Isaac Newton has again played a very important role and he has framed three laws when the objects are in motion here. So we'll see what are those three laws and in which places and all it's been applied and where we can see in our daily life. Okay, so we'll catch up in the next session. Thank you, children.